Hi everybody, Mrs. Pesic here,
And Miss Bella here.
and we are looking at section 10.1, right angle trigonometry. The objectives are to understand and use trigonometric relationships of acute angles in triangles and to determine side lengths of right triangles by using trigonometric functions. This section may seem familiar to you if you are in a Gold Day Algebra 2 class, because this section was your Blizzard Bag section number 2.
So a trigonometric function is a function whose rule is given by a trigonometric ratio. A trigonometric ratio compares the lengths of two sides of a right triangle. And the Greek letter theta, which again, here's a symbol for theta. This should look a little familiar from geometry. Theta is traditionally used to represent the measure of an acute angle in a right triangle. And the values of trigonometric ratios depend upon what that theta measure is. So again, this would be theta. It's an acute angle. We know this is a right angle because of this marking, so that's 90 degrees. And we're going to find out our side length. So we'll have these three sides of our triangle to figure out based on what the angle measure is. All right, so in words, if we take a look at our trigonometric functions, we have three that we're going to look at right now: sine, cosine, and tangent. So the sine of an angle is the ratio of the lengths of the opposite leg to the length of the hypotenuse. Again, remember, when I say hypotenuse, hypotenuse is always across from the right angle, and it will be the largest side in your triangle. The adjacent side is going to be the one that is right next to theta. It shares the, makes up one of the sides of that angle. And then opposite will be the one that is not touching across the triangle from it. So again, sine is opposite over hypotenuse. Cosine of an angle will be the ratio of the adjacent to the hypotenuse. And tangent will be opposite to adjacent. So a helpful way to remember that is that phrase SOHCAHTOA that hopefully you remember hearing. So the first letter in the saying is what trig function you'll use, and the next two letters are the ratio of the sides you'll use. So stands for sine, and you take the opposite divided by the hypotenuse. C is cosine, which is adjacent over hypotenuse, and T is tangent, so opposite over adjacent. The triangle shown at the right is similar to the one in the table shown up above because their corresponding angles are congruent. So no matter what triangle is used, the value of sine is always going to be the same if the angle measure is the same. So just kind of keep that in mind. Sine will always be opposite over hypotenuse. So this is just another example of what we would do here. The value of sine and other trig functions will depend on the angle only and not on the size of the triangle.
So are you saying that if we had, let's say, a right triangle that was a 20, 70, 90 triangle, that no matter how big that 20, 70, 90 triangle is, like let's say it's like a little tiny 20, 70, 90 triangle, or a much bigger 20, 70, 90 triangle, as long as they are still 20, 70, 90, then like the sine of the 20 degrees is going to be the same in either triangle.
Correct.
Okay, so it doesn't matter the size, as long as the triangles are similar, right triangles, then they're going to have the same trig ratios. All right, so let's take a look at example 1. We are finding the trig ratios. Find the value of sine, cosine, and tangent for angle theta. Again, we're going to be referring to that magic word SOHCAHTOA. And if we want to find the sine of an angle, that's going to be the sine of angle theta in this case is going to be the opposite over the hypotenuse. When we say opposite, we really mean the opposite leg. So the opposite leg from angle theta would be this side right here is 7. And the hypotenuse is the side across from the right angle, so that's 25. So the sine of theta is 7 over 25. If we want to find the cosine of angle theta, we're now looking at CAH, and the cosine is going to be the A stands for the adjacent leg over the hypotenuse. So in this case, the adjacent leg is 24, and the hypotenuse is still that 25, so 24 over 25. And lastly, if we want to find the tangent of angle theta, now we're talking about the TOA part of SOHCAHTOA. So the tangent is the O over the A, means opposite leg over the adjacent leg. And in this case, the opposite leg is that 7 right here, and the adjacent leg is the 24, so it's going to be 7 over 24. All right, you will frequently need to determine the value of trigonometric ratios for 30 degrees, 60 degrees, and 45 degree angles. as you solve trig problems. Recall from geometry that in a 30, 60, 90 triangle, the ratio of the side lengths is 1 to square root of 3 to 2. So in a 30, 60, 90, so if this angle here is 30 degrees and this angle here is 60 degrees, that short leg is going to be the one that's across from the 30. So this is the short leg, we'll call that x. And then that means that the hypotenuse across from the right angle is always going to be double that in a 30, 60, 90, and that's going to be 2x. And the long leg is going to be just that short leg times square root of 3. In a 45, 45, 90 triangle, the ratio of the side lengths is 1 to 1 to square root of 2. So the legs are going to be each congruent to each other. So if that's x, then this is going to be x. Again, this is a 45, 45, 90 right triangle. And the hypotenuse is going to be x times square root of 2. So the leg length times square root of 2. That means that we could, for example, let's say we wanted to find the sine of 30 degrees. We could just say 30 degrees, sine is the opposite over the hypotenuse, and the opposite would be x, and the hypotenuse would be 2x. So we would be able to reduce this, divide out the x's, and we really just get 1/2. So the sine of 30 degrees is 1/2. So here's the trig ratios of the special right triangles. This is the one that I just demonstrated here. Sine of 30 degrees is 1/2, but we could have done that with sine of 60 degrees, or cosine of 30, or cosine of 60, and so forth.
Again, this information here is actually going to tie in pretty nicely to trigonometry next year, and then we're going to be using some stuff out of this. So if you, even in the next chapter in this, in Algebra 2. So if you remember how to do these, good. If you need to keep working out like sine, cosine, like what are the side lengths or the ratios, and reduce it down, it's fine. But here's kind of a shortcut or a quick reference on what they will always come if you have those special right angles. So let's look at example 2. Now, how are we going to use these trig functions? Notice in order to use them, you always have to have a right triangle in order to make this work. So we're going to use a trig function to find the value of x. So I'm given a right triangle. Again, I know it's a right triangle based on my marking here of 90 degrees. And in this case, I was told that this angle up here has a measure of 30 degrees. Let's look at what we're given. We're given, in this case, this side length, which is 74. Since it's across from the right angle, we know we are given our hypotenuse, and we're asked to find this piece right here labeled x, which based on where my angle of 30 degrees is, this is actually my opposite leg. So if I think about what I'm asked to use, I have an angle and I have the hypotenuse and the opposite leg. So if I have the opposite leg and the hypotenuse, this is going to come from or SOHCAHTOA, my sine. Now setting this up, we can say that the sine of my angle, so sine of 30 degrees, this is going to equal my opposite leg, which is x, divided by my hypotenuse, which is 74. Now, we just talked about the 30, 60, 90 triangles and the special relationship that those angles have. So if you kind of think back to what we just did, we'll kind of make another one here we can mark up. If this was my 30-degree angle and this was my 60-degree angle, so this relationship was x, 2x, and x square roots of 3. So again, the shorter leg is x, hypotenuse is twice that, and the longer leg, crossing the 60, is x square roots of 3. So in this case, we were given that our hypotenuse was equal to 74. So if we know that this part here was my hypotenuse 74, we can say 74 is equal to 2x, and to find x, if I divide that by 2, my shorter leg here must have been equal to 37. So using special right triangles, that is one way that we could have approached that. Now, let's say we didn't remember those rules from the page before. So if I go back to what I set up here with SOHCAHTOA, if I wanted to solve for x, I could make this a proportion and have two ratios equal to each other. So put that over 1. Now I can cross multiply, and I would have 1 times x, which is x, is equal to 74 multiplied by the sine of 30 degrees. So I can get my calculator and plug that in to see what that's going to equal as well. So let's look at this on our calculator. So if I get my calculator open and I'm going to go to a calculator page, I'm going to type in 74 multiplied by the sine of 30 degrees. So if you go to the trig key next to the 7, I'm going to choose sine. I'll type in 30. Now you have to tell your calculator you're working with degrees. So if you go by the G, there's a little question mark button, and under there you'll see the degree symbol. So what is 74 multiplied by the sine of 30 degrees? tells you that that's 37. So again, you could have either used that shortcut or you could have used your calculator to help you find out that that side length that we're missing here is 37.
Okay, that brings up your first notes must do. You're going to use a trig function to find the value of x in this sketch. And I mean, you could find it using the special right triangles, but Ms. Bell and I would like you to use a trig function. So decide which trig function you're going to use to do that. Okay, so let's take a look at example 3, sports application. In a water skiing competition, a jump ramp has the measurements shown. To the nearest foot, what is the height h above water that a skier leaves the ramp? So the ramp has been built so it forms a 15.1 degree angle with the water, and the ramp itself is 19 feet long, and we're wondering what is the height of the ramp above the water. All right, so caution, make sure your graphing calculator is set to interpret angle values as degrees. All right, so in order to set up this problem, we want to use which trig function? Well, we are given the hypotenuse in this triangle, and we're trying to find the opposite side from the 15. So which trig function involves opposite and hypotenuse? Well, again, from SOHCAHTOA, it's the sine. So we need the sine of 15.1 degrees, and that's equal to h over 19. And so we can think of this sine of 15.1 degrees over 1. And when we cross multiply, we get h equals 19 times the sine of 15.1 degrees. And so when we grab our calculator to do this, we're going to type in 19 times the sine of 15.1, and remember to put in the degree symbol here with the question mark button, degree symbol, and that means it is approximately 4.95. Where are we at? So 14.95 would be the height in feet. Oh, I'm sorry, 4.95? What was it? 4.95, thank you. So 4.95 feet. Okay, so that brings up your next notes must do. This time's the skateboard ramp. It's going to have a height of 12 inches, and the angle between the ramp and the ground is 17 degrees. So to the nearest inch, what will be the length L of the ramp?
When an object is above or below another object, you can find distances indirectly by using the angle of elevation or the angle of depression between two objects. So if you look at your picture here, let's first talk about the angle of depression. So if we have this pilot in the airplane here, and if he's looking straight ahead, if he's looking down at something, then that's going to be called the angle of depression. So how far down will we have to look? If you are kind of down here on the ground now and you are looking up, so from this control tower, so if you would look straight out compared to looking up, however much that angle is, that would be your angle of elevation.
So it always has to be something with a horizontal line.
Correct. So between the horizontal line and where you're looking. So we're going to use that to kind of help us here for our example 4. A biologist whose eye level is 6 feet above the ground measures the angle of elevation to the top of a tree to be 38.7 degrees. So let's first draw a picture here. We know if we're using trig, we have to have a right triangle. So let's draw that in first. So in this case, we have that a biologist whose eye level is 6 feet above the ground. Well, that means that where his eyes are, again, I'm a math teacher, not an artist here, so there's my stick figure. Where his eye level is, he is 6 feet tall. Well, at least up to his eyes is 6 feet tall. He could be a little taller than that. That's 6 feet. And we know that he is looking up to the top of some tree that's over here. Okay, there's my tree. So looking up to the top of that tree, his angle of elevation in here is going to be 38.7 degrees. Again, we know we have to have a right triangle in here. All right, if the biologist is standing 180 feet from the tree's base, so this tree comes all the way down here, it's a big tree here, this is a total of 180 feet away, which means this side of the triangle is 180 feet. I want to know, what is the height of the tree to the nearest foot? Well, using this triangle that we've set up, we have right now, this side is 180, and I'm going to figure out how tall is this part of the triangle? Because if I can add that to the 6 feet that the biologist is already off the ground for eye level, I can find how tall the tree is overall. So using the triangle that we have here, let's look at what sides we're given. We have an angle measure, and we know that this part over here is my opposite leg, and this 180 is going to be my adjacent leg. So thinking to SOHCAHTOA, which one should I use if I have opposite and adjacent? Well, hopefully you're saying TOA. We're going to use tangent here. So we will say tangent of my angle, which is 38.7 degrees, is equal to the opposite, so opposite is x, over the adjacent, which is 180. So in order to solve for x, I'm going to put this over 1, and I'm going to cross multiply. So I'm going to have 1x is equal to 180 multiplied by the tangent of 38.7 degrees. So let's go to our calculator and figure out what that is. So 180 multiplied by the tangent, so choose tangent here. I got to check back for a second. All right, 38.7. And make sure you tell your calculator you're calculating degrees. And it tells me that that opposite leg is 144. I'm just going to round to the nearest foot there. 144 feet. So how does that help us answer our question? We now know that this part, this x, is equal to 144 feet. I want to know what the total height of the tree is, so we have to remember that this wasn't from the ground, the 144, but instead I had to account for the 6 feet that would take you from the ground to eye level. So if I take 144 feet and add it to 6, I'm going to say that my tree is approximately 150 feet tall.
And this tree is really like, I mean, here's the top of the tree. Yeah. Like,
I'm not a very good artist. Hopefully we got the idea.
no, it looks great. Okay, so that brings up notes must do number 3. A surveyor whose eye level is 6 feet above the ground measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.7 degrees. If the surveyor is standing 120 feet from the hill's base, what is the height of the hill to the nearest foot? So again, it's going to be a very similar problem to the last example. So work on that. Make sure you draw a nice, accurate sketch. All right, the reciprocals of sine, cosine, and tangent ratios are also trig ratios. They are trigonometric functions, cosecant, secant, and cotangent. Cosecant is abbreviated CSC, secant is abbreviated SEC, and cotangent is abbreviated COT. But we still, when we see them, we still read cosecant, secant, and cotangent. All right, and so cosecant, since that's the reciprocal of sine, instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Secant is the reciprocal of cosine, so instead of adjacent over hypotenuse from SOHCAHTOA, it's going to be hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so instead of TOA, instead of opposite over adjacent, it's going to be adjacent leg over opposite leg. Okay, so, and just to hammer this home, so if we are looking at the cosecant of this angle theta, the sine would be the 4 over the 5 for opposite over adjacent, opposite over hypotenuse, but the cosecant is the reciprocal, so it's going to be the hypotenuse over the opposite, so it's 5 over 4. Okay, so example 5, you're finding all 6 trig functions of angle theta.
All right, so let's start off with the ones that we know from the saying. Let's do SOHCAHTOA first. So SOHCAHTOA, just to remind ourselves. So sine of angle theta, if I look at my triangle, let's label what we know. Across from the right angle, this is going to be my hypotenuse. Adjacent leg will be right here, and opposite leg will be the 70. Now, if I'm taking a look at this, I notice I have 2 out of 3 sides of my triangle, and I'm going to need all 3 of them in order to find these trig functions. So we got to do a little recall from geometry and use that Pythagorean theorem, where a squared plus b squared is equal to c squared, where c is always your hypotenuse. So this is going to help us figure out what the missing hypotenuse is. So let's let a be my adjacent side, so 24 squared, plus b will be my opposite side, 70 squared. That's going to equal whatever my hypotenuse is squared. So again, let's use our calculator here to multiply some of these. So 24 squared, if I do that, that is equal to equal to 576. Again, if it makes you feel better, 70 squared would be 4,900. So we're going to take those two, plug these back in here for a second so you see what we're doing. Maybe if I can get to click over. There we go. So 576 plus 4,900, that is equal to c squared. So if I add them together, let's see, this is going to give us a 6, a 7, a 4. 5,476 is equal to c squared. And to solve for c, well, to undo a square, I would square root both sides. Usually we would put a plus or minus here, but I can't have a negative side of my triangle, so really I only care about the positive answer that I get. So if I take the square root of 5,476, yeah, let's see a decimal what it is to help us out. So square root 476. So it equals exactly 74, which works out nice for us. So we know this is equal to 74, so our hypotenuse is 74. So now we can actually find out what those ratios are. You always need all three sides.
That would make 24, 70, and 74 Pythagorean triple.
It would be. Hopefully remember what that means. It's three whole numbers that make up a right triangle.
Make up the side lengths of a right triangle, yeah.
All right, so back to sine. Opposite over hypotenuse. Well, opposite now is 70 over the hypotenuse, which is 74. We could always reduce that down to 35 out of 37. Our cosine is going to be the adjacent over hypotenuse. So adjacent is 24 over the hypotenuse, which is 74. I could reduce that down to 12 over 37. And my tangent of theta will be opposite 70 over adjacent 24, which will reduce to 35 over 12. Now, Mrs. Pesic, do you want to do the inverse one?
Sure.
The reciprocals?
All right, so the reciprocal of sine is cosecant. So we're going to say the cosecant of theta is, since that's 1 over the sine of theta, it's going to be the reciprocal of 35 over 37. So we're going to just flip that and say that's going to be 37 over 35. The secant is the reciprocal of cosine, so 1 over cosine is going to be 1 over 12 over 37, so that's going to be 37 over 12. And if we want the cotangent of theta, that's the reciprocal of tangent, so 1 over tangent is going to be the switch of these two, so we're going to get 12 over 35. All right, so those are all 6 trig functions of the angle theta. And that's it for this lesson. Hope you did all the notes must do's and took good notes, and we'll see you next time.